Right. Okay. Students, can you all hear me? Can you hear me, students? Right. Okay. Right. Okay. So good evening for all of you. So today we are going to start the paper book 6. Right. We completed 5 paper books. So we discussed a lot of papers, and this is the 6th paper book. And hereafter we are going to continue our paper class in this time. That means Friday night. Okay. Friday night, 8 p.m. to 11 p.m. We are going to continue our paper class. Okay. Right. Okay. So I believe that you got the paper book, everyone, right? So there was one newcomer today. I think I have sent you the tube today actually. So you will get that one before the next class. And what about the others? Did you get the tutorial? All of you? Paper book 6. Can I? Right. Good. Then did you try the first paper? So actually in the first model paper, so those who don't have the paper book with you, you can refer the PDF that I have uploaded to the WhatsApp group. So did you try the MCQ paper? Actually, there are 30 MCQs, 2 structured essay questions, and 2 essay questions are there. Remember, students, hereafter for each and every paper, I'm going to give you a marking scheme. For the MCQs, I'm going to give you a review, but that will be given after the complete discussion of that paper. Okay. If not, if I give you the uh, paper, the marking scheme or the review for that one before, so no point. So therefore, better we do the discussion of the paper completely without missing any question, and then we can have the MCQ review and marking scheme for the structured essay questions and the essay questions. Okay, right. Now let's go for the model paper number 1. So first MCQ. So now we are going to discuss about the model paper number 1. MCQ. So the first MCQ, what they have given, the element with the highest atomic radius is, right? So they have given few elements: sulfur, chlorine, argon, potassium, and calcium. Remember, when we are doing these kind of questions, better you revise the theories that you learn. We know that atomic radius is decreasing along a period. What will happen to the atomic radius along a period? Decreasing. Atomic radius decreases along a period from left to right. From left to right, these are the simple theories you learn in the first meet. And the next thing is, you know that down the group, what will happen to the atomic radius? Down the group, atomic radius is increasing. Atomic radius increases down the group. Okay, so these are very simple theories we learn. Then students, according to the question, they have given sulfur, chlorine, argon, potassium, calcium. We know that in the periodic table, these elements are located actually. Let's go for the second period: lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. Then here we have sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon. Okay. And then, so here we have, you are given sulfur. Where is sulfur? Yeah, this is sulfur. Then chlorine is given, argon here, potassium and calcium is also given in this way. Students, you know that sulfur, chlorine, argon, these 3 elements are belong to the 3rd period of the periodic table. Potassium and calcium, they both are belong to the 4th period of the periodic table. Then definitely potassium and calcium both have a greater radius than sulfur, chlorine, argon. Now you have to go for a comparison between potassium and calcium. That's very easy because we know that atomic radius decreases along a period from left to right. So therefore, potassium has the greatest radius. So the radius of potassium is greater than radius of calcium. So therefore, we can see that among the given elements, the highest atomic radius belong to potassium. Question number 1, answer is fourth one. MCQ number 1, answer is fourth one. Very easy. Raise your hand who got the correct answer as fourth one. Raise your hand who got the answer as fourth one. Okay. Remember, students, actually, I have given you an marking sheet also. Did you see that one in the page number 5? I have given you marking sheet for the 30 MCQs. You can mark your answers there. And finally, you can count that how many questions are correct. There are 30 MCQs. Out of 30 MCQs, how many MCQs that you got correctly, right? And what are the mistakes you have done? You can count that one, okay? I told you that from the paper book 6, actually, the paper class will be organized more than before. So because this is the phase 2. In the phase 3, we are going to discuss about the full papers in the last 3 months before the exam. Okay, right. So therefore, MCQ question number 1, answer is fourth one. Second one, question number 2. If you want to note down anything, quickly note down. Huh? The molecular ion having a different electron pair geometry compared to the other molecules of ions. Let's see how we can do this one. They're asking which compound has a different electron pair geometry compared to the others. Okay, so let me go for the 5 compounds that they have given. Look at this one. This is very easy, students. In question number 2, they have given 5 compounds like PCl3, NO2 minus, methane CH4, water molecule, and ammonia. So let's quickly draw the Lewis structures for these molecules. PCl3, the Lewis structures look like this. The PCl3 Lewis structure is look like this. And tell me what is the electron pair geometry and the shape of molecule. What is the electron pair geometry? Electron pair geometry for this one is, what is it? Tetrahedral. Because there are 4 Vesper pairs. And what is the shape? We can tell that the shape of the molecule is trigonal pyramidal. Trigonal pyramidal. If you go for the NO2 minus, look at the Lewis structure for NO2 minus. NO2 minus look like this. We can say that there is a lone pair on nitrogen and oxygen is containing the negative charge. So the electron pair geometry for this one is trigonal planar. What is the shape of molecule? Shape of molecule is angular. NO2 minus. Next one, methane, very easy. Methane CH4. Carbon is surrounded by 4 hydrogen atoms in this way. We can say that the electron pair geometry is tetrahedral. Shape of the molecule also tetrahedral. Next one is water molecule. Very easy. Oxygen is surrounded by 2 hydrogen atoms. We can tell that electron pair geometry is tetrahedral, and then we can tell that the shape is angular. Right? Ammonium cation. Nitrogen is surrounded by 4 hydrogen atoms. In this way, we can say that the electron pair geometry is tetrahedral. And we can say that the shape of the molecule also same as that one, tetrahedral. Then you can identify here the molecule ion having a different electron pair geometry. PCl3, methane, water molecule, ammonium, all of them have the tetrahedral electron pair geometry, but in NO2 minus, nitrite and iron, we are having trigonal planar electron pair geometry. So therefore, question number 2, answer is second one. Question number 2, answer is second one. Check whether your answers are correct or wrong. Question number 2, answer is second one. Now let's go for the question number 3. Question number 3 is actually related to D block. We didn't discuss the D block colors yet, but in the last Saturday theory class, we started D block. So in the upcoming weeks, these theories will be covered. But yeah, let's see what is the answer for this one. Quickly complete this one. If you want to note down anything, quickly note down. Quickly, huh? Okay, are we done? Next question, question number 3. The correct statement regarding COOH 4 times 2 minus iron. Remember, students, the question number 3, third question is related to the cobalt compounds, the complexes formed by cobalt. Let's see. Let's see how we can go for the answers for this one. First of all, what we have to know about cobalt. Remember, students, under the D block, we are going to discuss about cobalt. Cobalt is forming cobalt 2 plus cation, and this cation is making some complexes, right, and compounds. You have to remember the colors of these compounds as well. So here, the first thing actually you have to know is cobalt is forming hexa aqua cobalt 2 plus cation. This is aqueous cation, which is pale pink color. Remember, this is pale pink color. And the next thing is cobalt is forming a hydroxide compound, COOH twice. This is cobalt hydroxide, pink color precipitate. Pink color precipitate. And the next thing is cobalt is making an amine complex. So cobalt is making hexaamine cobalt 2 plus. This is the amine complex formed by cobalt. You can see that 6 ammonia ligands are connected to the cobalt 2 plus cation. And the color of this one is yellowish brown. Yellowish brown. Okay. And we can consider that when this cation, hexaamine cobalt 2 plus, when it is exposed to air, this cation is oxidizing. So when it is undergoing oxidation, it is forming hexaamine cobalt 3 plus. Hexaamine cobalt 3 plus. Remember, students, they have given that this cation is actually brownish red or reddish brown. Okay, brownish red or reddish brown cation. So therefore, you have to remember these things with the colors. And the next thing is cobalt is making chloride complex, tetrachloride cobaltate, right? So this is blue color complex. Students, remember in the examination, they're asking these things with the colors. You have to remember them. Okay. Very soon we are going to learn these things under the D block. So therefore, please remember these things. These things are very, very important, right? Here you can see that cobalt is forming the aqua complex. And here you can see that cobalt precipitate. And this is the chloride complex. This is the amine complex. And this is the complex formed by the oxidation of that amine complex. These are the things you have to remember under cobalt. Okay, quickly write down. As a summary, you have to remember these things under cobalt. I'm revising a theory part for this question. Okay. Quickly. We can just consider this one is pink color. Okay. Not pale pink, pink color. Right. Now let's go for the question. The correct statement regarding tetrahydroxide of cobaltate ion is the color of the aqueous solution of the ion is deep blue. Remember, students, now in this statement, you can see that in our resource book, these are the cobalt compounds they have given. They have given hexa aqua cobalt 2 plus cation. They have given a cobalt hydroxide compound, then chloride complex, and the amine complex of 2 plus cation and 3 plus cation. This is what they have given in our syllabus. These are the cobalt compounds they have given. So therefore, we don't know what is the color of this complex anion. Look at this one. In this question, they're asking about tetrahydroxide of cobaltate. Then how we can obtain the color of this one? Remember, someone can say that actually, since this one has the format of this chloride complex, COCl4. So this is COOH 4 times. So someone can say that this is also blue color. But remember, in order to show a color, the ligand is also effective. So we cannot exactly tell that is blue color. So therefore, we can consider this statement correct or wrong. Both are correct, right? Someone can say that this statement is correct, and another one can say that this statement is wrong. Okay. Then let's go for the other statements. The oxidation number of cobalt in the ion is -2. Yeah, that's correct, because we know that cobalt, let's take the oxidation state as X. OH minus -1 into 4, summation is equal to -2. Then X minus 4 is equal to -2, X equal +2, oxidation state of cobalt is +2. So therefore, the second statement is correct. Second statement, they have given -2. Oxidation state of cobalt is -2. But what is the correct answer? +2. So therefore, second statement is also wrong. Third one, the coordination number of cobalt in the ion is 2. Coordination number means, remember students, coordination number means how many ligands are connected there, right? How many electron pairs approaching this cobalt 2 plus? You can see that cobalt is actually connected to 4 hydroxide ligands. So therefore, coordination number here, it is 4. It's not 2. So therefore, this statement also wrong. Third statement also wrong. The total number of electrons in the given ion is 28. Is that correct? Students, you can see that there are almost 4 oxygen atoms, 4 hydrogen atoms, 1 cobalt. Even in the cobalt cation, cobalt is atomic number 27. So after removal of 2 electrons, just imagine we have 25 electrons. Then anyway, we have more than 28 electrons. So therefore, that statement is also wrong. Fifth one, there are ionic bonds between cobalt 2 plus ion and OH minus ion. Is that correct? No. Remember, these are complex anions, right? These are complex compounds. Under the third unit also, I taught you this one, right? At there, I told you that these ligands are connected to the metal cation through a dative covalent bond. It's not an ionic bond. So therefore, the statement they have given is wrong. This is not an ionic bond. We cannot see any ionic bonds. So therefore, try to understand the fifth statement is also wrong. 2, 3, 4, 5 statements are wrong. So if you consider first statement is correct according to that logic, right? Since there are 4, this is in the format of this chloride complex, then we can say that blue color. And someone can argue that this is not the color, it's not the blue color. So therefore, For the third one, we have two options. Someone can say that the correct one is first one. If not, we have to consider all the 5 statements are wrong. If all the 5 statements are wrong, I can give you all for this question. Okay. So therefore, third one, this is the option. In the examination paper also, we can see questions like this. So therefore, yeah, we have to face these kind of questions. Okay, are we done? If you have any doubts, put your doubts in the chat box. Huh? So can you please explain about the coordination number? Right. Now look at this one. Gimani. Coordination number means simply we can tell that the ligands, that means the lone pairs, or else the number of atoms connected to the cation. Now cobalt 2 plus. We know that cobalt 2 plus cation is surrounded by 6 water molecules. So therefore, we can see that 6 oxygen atoms are approaching, connecting to that cobalt 2 plus cation. Then we can tell that the coordination number is 6. How many bonds are there? How many dative covalent bonds are there? So there are 6 bonds, right? And here you can see that ammonia. In ammonia ligand, nitrogen is giving electrons for the cobalt 2 plus. And then how many bonds then cobalt is formed there? 6. Then we can tell that coordination number is 6. Here also same thing. There are 6 ammonia. Coordination number is 6. What about tetrachloride cobaltate? Coordination number? Coordination number here it is 4. Because there are 4 chlorine atoms connected through bonds, dative covalent bonds. Tetrahydroxide cobaltate. 4 OH minus ligands are connected to the cobalt 2 plus cation. Then the coordination number means 4. So that means the number of ligands are always equal to the coordination number. No, it's not correct. Remember, students, some of the ligands are there. They are connecting to that metal cation by 2 positions. Right? That means from left hand side it's forming a bond. From the other side also the same ligand is forming a bond. Right? So therefore, one ligand is forming 2 bonds with that metal cation. Then we have to count the coordination number as 2. Right? For example, now imagine, now for an instance, this chlorine atom, chloride anion, is connecting to the cobalt 2 plus cation from both sides. That means 2 lone pairs are given. Then so 4 chlorine ligands are there. Then how many bonds are there? 8. So therefore, the coordination number will be 8. Right? So for an instance, that is not correct. So here coordination number is 4. So we can't say that the coordination number is equal to number of ligands always. According to these compounds, that's correct. Okay. Actually, this is given in your all syllabus before 2017. But in the new syllabus, actually, they haven't asked that. Those are known as monodentate, didentate ligands. Right? Didentate ligand means the ligand can give the lone pairs for the metal cations from both sides. Right? That means there are 2 lone pairs can give the electrons for that cation. But here we are not considering that way, right? We are considering atom, a particular atom is giving 1 lone pair for that metal cation. Then the coordination number is 1. Okay? Keep that in your mind. Don't think about that one too much. So here we can just counting. By counting the ligands, you can take the coordination numbers. Right? Okay. So doesn't the charge effective? No. For the coordination number, charge is not affecting. The affecting factor for the coordination number is always ligands, right? Ligands are the affecting factor. Right. Students, now let's go for the question number 4. Did you write down this one as a summary? These are the exact colors they have given in your resource book. So therefore, you have to remember these things. In the examination, they ask you. Okay, keep that in your mind. In the theory class, we are separately discussing these things. So let's see. Question number 4. Question number 4 is related to unit number 5, enthalpy. So normally in the examination, students, we can expect these kind of enthalpy type of questions. Let's see what we have to learn under this question. So this is a very nice question. Consider the following reaction taking place at 25 degrees Celsius. So what is the question? What is the reaction they have given? Carbon monoxide is reacting with oxygen gas, half oxygen gas, and producing carbon dioxide gas CO2. Producing carbon dioxide gas CO2. The standard molar enthalpy for above reaction is minus 283 kilojoules per mole. So the enthalpy change for this reaction, they have given it delta H theta minus 283 kilojoules per mole. The standard molar entropy change, delta S theta also given minus 86.6 joules per mole per Kelvin. Joules per mole per Kelvin. The correct statement regarding the above reaction is, let's see. The first statement, the reaction does not take place spontaneously at 25 degrees Celsius. What do you think? Okay, then we have to find out at 25 degrees Celsius what will happen to this reaction. Can you remember, we learned that delta G theta is equal to delta H theta minus T delta S theta. Right? This is the reaction for Gibbs free energy, equation for the Gibbs free energy. And I told you that if the delta G theta is less than 0, the reaction is spontaneous. Right? If delta G theta value is greater than 0, we tell that the reaction is non-spontaneous. If the delta G theta value is equal to 0, we tell that the reaction is in equilibrium. Right? Then students, listen this one carefully. By applying for this equation, substitute the values, find out the delta G theta. Enthalpy change minus 283 kilojoules per mole. And here we can say that T, temperature is 25, that means 298 Kelvin, multiplied by, here we have minus 86.6, 10 to the power minus 3 kilojoules per mole per Kelvin. I converted that one into kilojoules. Kelvin per Kelvin cancel off. Then the answer, delta G theta minus 283 kilojoules per mole minus, we can tell that 2.98 and 8.66 kilojoules per mole. Students, you don't have to do the calculation for this one. Don't go for the final answer. Why? It's not necessary. So approximately you can tell that this is about 3 vagi. So you are going to multiply 8.7, approximately this is 8.7 multiplied by 3. So then when you multiply 8.7 by 3, so you can say that answer is about 1, 2 here, 24, 26, minus 26.11. Then this is also negative value. This is also negative value. Then delta G theta is a negative value. Right? So if you want to do the calculation, do that one, doesn't matter. You will get the answer. Yeah, you have to do that one and get the answer. So here we have to find out whether the reaction is spontaneous or not. Then we know that final answer is negative because this multiplication is giving a negative value. Negative value is negative. Then we can say that at 25 degrees Celsius, Reaction is spontaneous. It's confirmed. Spontaneous. Okay. Then they have given the reaction does not take place spontaneously. Then the first statement is wrong. Right? We have clearly proven that the reaction is spontaneous at 25 degrees Celsius. Right? So the first statement they have given is wrong. Second statement, the entropy change for the above reaction, for the reaction above, a temperature of 200 degrees Celsius is a positive value. Students, look at this only. Now, whatever the temperature is, right? Whatever the temperature is, we know that what is the entropy change for this reaction? Negative value. It's a negative value. You can see that here we have 1.5 gas molecules. Here we have one gas molecule. That means number of gas molecules are reducing. Number of gas molecules are reducing. Therefore, we can tell that the entropy change is always a negative value. Right? Whatever the temperature, the entropy change is negative value. Then we can tell that the statement they have given is wrong. Because they have given the entropy change for the reaction above a temperature of 200 degrees Celsius is a positive value. That's wrong. That's wrong. Number 3, the reaction is not spontaneous. Temperature above 3000 degrees Celsius. Oh my God. 3000 degrees Celsius. Is that correct? Okay. Now again, let's go for the equation. Students, you know that. Look at this expression. Delta H theta value is a negative value. Ne? This is a negative value. And temperature is 3000 degrees Celsius. That means in Kelvin, 3273 Kelvin. Delta S theta also a negative value. Then this negative is becoming a positive value. Positive 3273, right? Something. And again, when you substitute here the entropy value, so this become more large value. And this is a negative value. Then what you can say? What you can say? Remember, you have a large positive value and a small negative value. What is the answer? If you have a large positive value and a small negative value, the summation is a positive value again. So therefore, delta G theta is positive. Delta G theta is positive. At 3000 degrees Celsius, the reaction is non-spontaneous. Non-spontaneous. Keep that in your mind, right? You don't have to do the calculations. You just substitute the temperature value. So we know that this is a large value. So therefore, this T delta S term becomes a large negative value. Negative multiplied by negative, then it becomes a positive value, a large positive value. Here we have small negative value, then the summation is positive value. At 3000 degrees Celsius, the reaction is non-spontaneous. So therefore, we can say that the reaction is not spontaneous. Temperature about 3000 degrees Celsius, correct. Question number 4, answer is third one, right? But we have to go for the other two statements also. Let's see. The reaction takes place spontaneously at any temperature. No, it's not like that. Not at any temperature, right? So we can say that now in the 3000 degrees Celsius, what happened? What happened to the reaction? The reaction is not spontaneous. So therefore, at any temperature, the reaction is becoming spontaneous. We can't accept that part. That is wrong. That is wrong. Number 5, the reaction exists in equilibrium at 25 degrees Celsius. Students, we did the calculation at 25. At there, we had a value, a negative value. So it is not 0. So therefore, we can tell that, what is it? Delta G theta at 25 degrees Celsius not equal to 0. So therefore, third statement is the correct one. Third one is the correct answer for question number 4. No, Pranali. Pranali, at there actually you will get a small value. Can you remember? Minus 283 kilojoules per mole. At 25 degree, this is 298 Kelvin. So delta S theta is minus 80.6, 86.6, 10 to the power minus 3 kilojoules per mole per Kelvin. So you have to multiply this one by 10 to the power minus 3. Then what will happen? Minus 283 kilojoules per mole. Yeah, as you said, this becomes a positive value. But that positive value is small, 2.98, 8.66 kilojoules per mole. Right, Pranali? This multiplication, the answer is lesser than this value. So therefore, final answer become negative. Okay. If you want the answer for this one, you have to use logarithms. Okay. 2.98 multiplied by 8.66, then 25.81. Then you can see that the final answer is a negative value. Okay. So you have to be very careful with the units and everything. 1 here, so 2 means 7, 5 in this way. Minus 257.19 kilojoules per mole. At 25 degrees Celsius, this is the Gibbs free energy. Okay, right. Right. Okay, are we done? Question number 20, question number 4. It's like this. Let's move for the question number 5. Question number 5. V cubic decimeter of oxygen gas was collected by the downward displacement through water at temperature T degrees Celsius and pressure of P Pascal by the heat dissociation of sodium nitrate in the laboratory. If the saturated vapor pressure of water at T degrees Celsius is P dash, the number of moles of oxygen gas produced. So students, we have discussed these kind of questions in previous papers also, right? Can you remember? So we can draw the diagram in this way. Let me draw a diagram quickly. So they have taken a sodium nitrate sample. So this is the Bunsen burner. Using the Bunsen burner, you are going to heat this one using a boiling point, boiling tube. And here in this way, we have the tube where oxygen gas is oxygen gas collected through the downward displacement. Okay. In this way. Okay. So you can see that the reaction is this is sodium nitrate. Sodium nitrate is thermally decomposing in order to form sodium nitrite and oxygen. We have learned this one under S-block theories, sodium nitrite and oxygen. So this oxygen is going through this tube and so it is collected in this measuring cylinder. So remember students, so this is the area that the gas is collected. So this is the oxygen gas. But remember, with the oxygen gas, I taught you this one, water vapor is also collected. That means in this area, in this volume, water vapor is also there, saturated vapor pressure. Right? Saturated water vapor pressure means the maximum pressure can created by water vapor particles. So if I consider total pressure inside this volume, in this area, total pressure P, this is equal to pressure created by oxygen gas, pressure created by water vapor. Remember, this is saturated, P naught. That means the maximum pressure created by water. So you will learn this one in heat lesson in physics, right? Then we have to find out, so what is the total pressure they have given? So the total pressure is P and saturated vapor pressure is P dash. P dash. Okay. Then you can see that the pressure created by oxygen is P minus P dash. This is the pressure created by only by oxygen gas. This is the pressure created by oxygen gas, partial pressure of oxygen gas, P minus P dash. Then they're asking the number of moles of oxygen gas. Then you can apply PV equal nRT for the oxygen gas. Very easy. PV equal nRT. So N equal PV over RT. So what is the pressure created by this oxygen gas? P minus P dash. Remember students, in this question, they have given the volume is V cubic decimeter. When we are applying this V value for the ideal gas equation, we have to convert that one into cubic meters, 10 to the power minus 3 cubic meters. Universal gas constant, we have to take that one as it is. And the temperature is substituted by the absolute temperature, right? So here they have given degree Celsius, then T plus 273. So check whether this option, this answer is given in which answer? Question number 5, answer is first one. Question number 5, answer is first one. Very easy. Okay. You have to understand these things very, very easy. Quickly. Question number 5. Question number 6 also in organic chemistry theories. Quickly come to this one. Right, okay. Are we done? Shall we move to the next one? Right. Question number 6. Which of the following can be used to distinguish the solutions of calcium chloride and strontium chloride. So they have given 5 compounds. Let's see by using which compounds we can write down, we can differentiate, we can distinguish these two solutions. Let's see. So here they have given calcium chloride and strontium chloride. So for these two solutions, students, they have added potassium nitrate, potassium sulfite K2SO3, sodium chromate Na2CrO4, sodium carbonate Na2CO3, sodium phosphate Na thrice PO4. So when we add these compounds for calcium chloride and strontium chloride, so what we can observe, what is the compound formed by the calcium? We can tell that it is producing calcium nitrate. Then strontium nitrate is produced by here. Remember, students, as a theory, we learned that all the nitrates in S block are water soluble. So this is a theory point we learned. All the nitrates in S block are water soluble. So therefore, these are completely water soluble. We can tell that aqueous, AQ. Then the next two compounds, calcium sulfite can be produced from this one, and strontium sulfite can be produced from this one. What do you think? Calcium sulfite and strontium sulfite, what are they? Are they soluble or are they insoluble? Calcium sulfite and strontium sulfite. Remember, these two are insoluble. Can you remember the table that I gave you? I told you that in the resource book, they have given a table, a big table. We have to remember. So this question is related to that big table. We have to remember the solubility of the compounds. All the nitrates are water soluble, right? Calcium sulfite, strontium sulfite, these sulfite compounds are insoluble. Now let's go for the calcium chromate and strontium chromate, right? Look at this one. What is the compound formed by this one? Calcium chromate. And here we have strontium chromate. Remember, students, here strontium chromate is insoluble. That means we can see the precipitate of strontium chromate in the solution. But calcium chromate is well soluble. So therefore, we can write down here aqueous. Then using these two solutions, using the sodium chromate solution, we can easily identify, we can easily differentiate calcium chloride and strontium chloride. Because when we add sodium chromate for calcium chloride, it's producing calcium chromate, which is water soluble. And this is producing strontium chromate, which is water insoluble. So therefore, we can easily differentiate them. Then what about sodium carbonate and calcium chloride? Calcium carbonate is produced, strontium carbonate is produced. Both of them are insoluble, right? They are precipitates, right? Go to that table I gave you. Both of them are insoluble. Next one, sodium phosphate added to the calcium chloride and strontium chloride. What will happen? Calcium phosphate is produced. Ca thrice, PO4 twice. And here, Cr thrice, PO4 twice. Remember, both of them are insoluble. Water insoluble compounds. So therefore, tell me, students, from which compound, right? From which compound we can differentiate calcium chloride and strontium chloride? Using sodium chromate. Because you can see that when we add sodium chromate, calcium chromate is soluble. That means the solution is completely aqueous. And in the presence of strontium chloride, it's producing a precipitate, insoluble precipitate. So therefore, you can differentiate these two solutions by using sodium chloride. Question number 6, answer is third one. Question number 6, answer is third one. Okay. Sixth one, answer is third one. Remember, these theories are very important. Okay, students, do you have any doubts, anything? Are we clear? Okay, now let's go for the question number 7. Question number 7 is a calculation. Urea is produced by the reaction between ammonia and carbon dioxide according to the following reaction. So students, they have given the reaction. The mass of urea that can be produced by reacting 68 grams of ammonia with 132 grams of carbon dioxide is, right? First of all, let me write down the reaction they have given. Look at the reaction they have given. So they have given ammonia gas is reacting with carbon dioxide gas to produce a urea. So urea is actually kind of a compound like this, NH2, NH2, A plus, and producing H2O liquid. Okay, and in order to balance the reaction, we have to put here 6 hydrogens, 2 oxygens, 1 carbon. So the reaction is balancing perfect. So this is the balanced reaction. We have given the balanced reaction. Then what is the mass of your compounds they have added? 68 grams of ammonia. Carbon dioxide, 132 grams of carbon dioxide. Then try to understand ammonia molar mass. What are the molar mass of ammonia? 14, 1 into 3. So the summation is 17 grams per mole. And we know that carbon dioxide is 44 grams per mole. Carbon dioxide is 44 grams per mole. Then divide the mass by its molar mass, 17 grams per mole. And here you can see that 44 grams per mole. So grams will cancel off here. So 1 here, you can see that this is 3 moles of carbon dioxide. And here 4 moles of ammonia. Now here you have to identify who is the limiting reagent, right? Because you can see that we have added 4 moles of ammonia, 3 moles of carbon dioxide. Then we have to identify who is the limiting reagent. Students, according to the reaction stoichiometry between carbon dioxide and ammonia, right? So what is the reaction stoichiometry? Carbon dioxide, ammonia, 1:2. According to this reaction stoichiometry, 3 moles of carbon dioxide should be reacted with 6 moles of ammonia. And then we don't have 6 moles of ammonia. Then carbon dioxide is not the limiting reagent. So then the limiting reagent here, it is what? Ammonia. So limiting reactant or limiting reagent is ammonia. So we can tell that 4 moles of ammonia reacting with 2 moles of carbon dioxide in order to produce, according to the reaction stoichiometry, 2 moles of urea, right? Then we have found here what is the amount of urea produced. They are asking what is the mass of urea that can be produced. Now you can find out, right? Number of moles of urea, we have found it as 2 moles. What is the molar mass of urea? Molar mass of urea, 1 carbon, oxygen, 2 nitrogen, 28, 4 hydrogens, 4. So therefore, we can tell that 28, 56, 60 grams per mole. And then in order to find out the mass of urea, you have to multiply the number of moles by its molar mass. Then the answer will be 120 grams. So the mass of urea is 120. So question number 7, answer is 4th one. Question number 7, answer is 4th one. Easy. So that's an easy calculation. No? It's not difficult. Please raise your hand who understood that calculation quickly. Please raise your hand. Okay, good. If you have any doubts, tell me, right? If you have any doubts, put your doubts in the chat box. Right. Now let's move for the question number 8. Question number 8. The IUPAC name of the following compound K2COCl4. Right. Students, this is very easy. IUPAC name. We learned this one in unit number 3. So they have given a complex compound K2COCl4. So how do you write down the IUPAC name for this one? First of all, you have to separate the cation and the anion. Cation is potassium and the anion is COCl4 2 minus. When we are writing down the IUPAC name, first of all, we have to write down the cation's name. Cation's name is potassium. Then leave a space. Start to write down the anion. Here you can see this is a complex anion, COCl4 2 minus. So in a complex anion, we know that there are two properties. The first one is the metal cation and the ligand. So here you can see the ligand type is chloride, Cl minus. When we are writing the name of the complex cation or complex anion, we have to start the name with the ligand. So here we have chlorido, then potassium tetrachlorido. That's all we have as ligands. Then go for the cation, cobalt. Remember, we can't just write down cobalt here because this is a complex anion. In the case of complex anion, we have to put the cobaltate. 8 suffix should be added. What is the oxidation state of cobalt? X minus 4 minus 2, X equal plus 2. So therefore, cobalt's oxidation state is 2. Put that one in simple parentheses using capital Roman numbers. Potassium tetrachloride cobaltate 2. This answer is given in the 5th one. Question number 8, answer is number 5. IUPAC nomenclature, right? We discussed these things. So don't we have to mention the prefix di to potassium? No. Remember, so this 2 means actually this 2 belongs to the complex anion. This 2 came by the complex anion. This 2 belongs to the complex anion. So potassium is actually potassium plus. And potassium not having 2 potassium, Yeah, in the complex compound, we have two potassium, that's correct. But remember that when we are separating the cation and anion, you can see that the 2 belongs to anion. So therefore, it's not dipotassium. That's wrong. We can't write like that. That is wrong. Okay, Kavisha. Right, okay. Now, let's go for the next question. Question number 9. So that is a calculation related to redox. That's very easy. We have done these kind of questions before. So therefore, these questions are not that much hard. Let's see. Question number 9. 24 cubic centimeter of 0.1 moles per cubic decimeter of potassium permanganate. Solution was required to completely react with 25 cubic centimeter of a certain ferrous oxalate solution in acidic medium. The concentration of ferrous oxalate solution in moles per cubic decimeter. Easy. Let's see. Students, we have here in acidic medium, permanganate MnO4 minus is reacting with ferrous oxalate. I taught you that if they have given the ferrous oxalate, we have to be very careful. The reason is in ferrous oxalate, the specialty of ferrous oxalate is both the cation and anion oxidizing. Fe2 plus converting into Fe3 plus, oxalate is converting into carbon dioxide, MnO4 minus is reducing into Mn2 plus, and the definite byproduct is water. In this way. Then we can see that manganese oxidation number here it is +7. Here manganese oxidation state is +2. +7 to +2, we can see that decrement is 5. Okay. And here we can see that iron, right? Oxidation state is +2. Here oxidation state is +3. Carbon, there are 2 carbon atoms. Summation of oxidation state of 2 carbon atoms +6. There are 2 carbon atoms here +8. Then you can see that it's going from +8 to +11 because take the total increment. When you take the total increment, +8 to +8, +3, +11, and this is +8. +8 to +11, the total increment is 3. Therefore, in order to equalize the total increment and decrement, we know that balancing a redox reaction means we have to equalize the total increment and decrement. Therefore, let me multiply this one by 3 and this one by 5. So put here 5, 5 here, then 2 into 5 is 10. And here when you multiply this one by 3, 3 here. Then students, you can see that the overall charge in the right hand side, is +15 and here +6. Then that is +21, right? Then in order to make 21 plus charge, we have to put here +24. Why? Because we have -3 charge here. That means there are 24 hydrogens. Since there are 24 hydrogens, we have to put 12 here. How many oxygens are there? 12 plus 20, 32 oxygens. 20 plus 12, 32 oxygens are there. So therefore, this is the balanced redox reaction. Now you can do the calculation. So they have given actually potassium permanganate concentration and the moles are given. Volume is given. The number of moles of potassium permanganate, what is it? 0.1 moles per cubic decimeter multiplied by 24 into 10 to the power minus 3 cubic decimeter. So then cancel off, the answer is 2.4, 10 to the power minus 3 moles. Friends, remember, you can see the reaction stoichiometry between permanganate and ferrous oxalate. That is 3:5. Then easily you can find out ferrous oxalate moles. For 3 permanganate, there are 5 ferrous oxalate. Then for 2.5 into 10 to the power minus 3, how much we have? 3 here, 0.8. Then the answer is 4 into 10 to the power minus 3. Ferrous oxalate moles are 4 into 10 to the minus 3. They are asking the concentration of this ferrous oxalate. FeC2O4 equals concentration equals to number of moles 4 into 10 to the power minus 3 divided by the volume of that ferrous oxalate is 25. Minus 3 cancel off. When you multiply this one by 4, you have 16 divided by 100 moles per cubic decimeter. Then the concentration is 0.16 moles per cubic decimeter. Ferrous oxalate concentration is 0.16 moles per cubic decimeter. Question number 9, answer is fifth one. Question number 9, answer is fifth one. Very easy. A simple calculation. Tell me if you have any doubts. Put your doubts in the chat box. Right, okay. Are we done? Shall we move to the 10th one? 10th question. Question number 10. The variation of Maxwell-Boltzmann curves based on the molar masses of three gases is given below. The correct order of the gases A, B, C are. Correct order. Right. Look at this one. Now, students, they have given three curves. This question is related to the Maxwell-Boltzmann. We learn in unit number 4, gaseous state of matter. Can you remember the diagram? At there, we discuss about the most probable speed. So this is the diagram for the Maxwell-Boltzmann distribution. Here they have given three curves. In this way. So for the y-axis, we can take that fraction of molecules. And for the x-axis, we can take that molecular speed. See, students, we know that when you consider this peak point of the each curve, it is representing the greatest fraction of molecules, and those greatest fraction of molecules have some kind of a speed, right? So I gave a name for that speed. What is it? Can you remember? That speed is known as most probable speed. That speed is known as most probable speed. So therefore we can tell that these speed values, this is VA, VB, VC. These actually VA, VB, VC are most probable speed values for each gas. What does mean by the most probable speed? Students, we know that. So this peak is representing the greatest fraction of molecules. When you consider the capital A gas, in the capital A gas, most of the molecules, right? Most of the molecules in the capital A gas is having this speed. That's what meant by the most probable speed. And can you see that the most probable speed is actually increasing for this direction? When you go for the B curve, that fraction of molecules are decreasing, right? When the speed increases, the fraction of molecules are decreasing, right? So when you go for the C curve, again the speed is increasing, but the fraction of molecules are decreasing, right? And this is related to the equation we learned, root mean square speed also, right? C squared bar 3RT over capital M. I told you that, right? Root mean square speed. So the root mean square speed is equal to 3RT over capital M. We know that the simple theory is when the size of the molecule, when the mass of the molecule increases, what will happen to the speed? The speed is decreasing. So therefore we can tell when the molar mass increases, the speed of the molecules are decreasing. You can see that ABC, which curve, ABC, which gas has the highest speed? VC. Then, so VC, that C gas should be the lowest weighted. That means that C gas should have the lowest mass among these three gases. Now, the gases they have given is hydrogen, nitrogen, chlorine. So chlorine is 35.5, so therefore 71 grams per mole. Nitrogen is 28 grams per mole. Hydrogen gas is 2 grams per mole. Then you can understand, students, the lightest gas among these three is hydrogen. Then hydrogen should have the greatest value of the speed, molecular speed. Then we can tell that, so this is hydrogen gas. C is actually hydrogen gas. Then B, so what is the next one? So the next one is nitrogen gas, and capital A should be chlorine gas. Remember, chlorine has the highest mass, molar mass, 71 grams moles. Therefore, we can tell that the speed is actually very low. Most of the molecules are having this speed, that is a very low speed. That means we can tell that that is the weighted, that is that gas has the greatest mass. Then ABC should be in this correct order. Answer is number 4. Question number 10, answer is number 4. Okay, now we have discussed 10 questions. Can you tell me that anyone here got 10 out of 10 for this first 10 questions? Anyone here got 10 out of 10? So I got correctly 10 out of 10. No one is there. Okay, then raise your hand. Who got 9? 8? Opeshani, Nuha, very good. 7? Lashmi. So many of you have gotten 7, eh? Right? Okay. Very good, very good. Okay, right, right. So you have to understand your mistakes, huh? So don't do those mistakes again, right? Okay, now these are the first 10 questions. Let's go for the 11th one. Right. Let's move to the question number 11. So students, from question number 11, you are given a statement type of questions. Let's see. Question number 11. Which of the following statement is are correct regarding the compounds formed by the elements of S block? All the bicarbonates are available in the solid state. Is that correct? I taught you that. So let's write down what are the bicarbonate compounds. Lithium bicarbonate, sodium bicarbonate, potassium bicarbonate, rubidium, cesium bicarbonate. Second group, beryllium bicarbonate, magnesium bicarbonate, calcium bicarbonate. Then we have strontium bicarbonate. At next, we have barium bicarbonate. Students, I gave you that under the bicarbonate. You take your theory note and check. All the second group bicarbonate compounds, yeah, and the, yeah, Asma, you came. All the second group bicarbonate compounds and the first group lithium bicarbonate, all of them are what? Available in the, not available in the solid form. That means we can tell that lithium bicarbonate aqueous, 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 all of them are aqueous in here. That means, students, we can say that these bicarbonate compounds are not available in the solid form, only in the aqueous form. Remember, these are not available in the solid form. Always they are existing in the aqueous solutions. Then what about sodium bicarbonate, potassium bicarbonate, rubidium bicarbonate, cesium bicarbonate? So these compounds can exist as solid as well as aqueous. So that is possible. Okay. So therefore, we can understand that one. So the statement they have given in question number 11, all bicarbonate are available in the solid state. Simple A statement is wrong. Okay, that's wrong. Keep that in your mind. Simple B, lithium bicarbonate is not available in the solid state. Is that correct? Yeah, lithium bicarbonate is not available in the solid state. It's always in the aqueous state. B statement is correct. C, all the carbonate of second group are thermally unstable. All the carbonates of second group are thermally unstable. Is that correct? Yeah, that's correct. Because we know that when we consider a carbonate compound, like just take magnesium carbonate. Magnesium carbonate, you are going to heat that one. Then it is producing magnesium oxide and carbon dioxide gas. So therefore, unstable. So when you give the heat, what will happen? They are decomposing. So therefore, the C is correct. Students, what do you think about the first group carbonate compounds? Sodium carbonate, lithium carbonate is thermally decomposing. Except lithium carbonate, other carbonate compounds in group number 1. Yeah, they are thermally stable. Thermally stable means there are no thermal decomposition reactions for these kind of compounds. Sodium carbonate, potassium carbonate, rubidium carbonate, cesium carbonate, they are thermally stable. They cannot form the corresponding oxide and carbon dioxide, except lithium. So lithium is having these kind of properties because of magnesium. We have learned that one has the diagonal relationship. Diagonal relationship. Then we can tell that here C statement is correct. When sodium nitrate is subjected to the thermal decomposition, NO2 gas can be obtained. Wrong. Wrong. False. We know that sodium nitrate thermally decomposing to produce sodium nitrite and oxygen gas. Can you remember in the question number 5 we discussed about this producing oxygen gas, and they have given sodium nitrate. So therefore it's not producing nitrogen dioxide. If it is a second group nitrate compound or lithium nitrate, then there is a chance to produce nitrogen dioxide. So therefore, so here the D statement is also wrong. We can say that B and C statements are correct. Question number 11, answer is second. Question number 11, answer is second. Right? If you want to note down these things, quickly note down. No? Right, okay. Are we done? Shall we move to the next one? Question number 12. Okay. Question number 12. Which of the following statement is correct? Enthalpy is a state function and extensive property. Okay, in this question, they have given extensive properties and the intensive properties. Yeah, let's see. Shall we revise the theory quickly? Extensive and intensive. What does mean by extensive? Extensive properties means the properties which are depending on the mass or the amount, right? Extensive properties depends on amount or mass, or else we can tell that size. What are the examples? Give me some examples for this one. So we can tell that volume, then we can take mass, then energy, number of moles. So these are actually depending on the amount of mass. So these are the extensive. Then intensive properties means opposite of this one. They are independent of amount of mass. So what are the examples for these things? So here we can tell that. So these are few examples: density, we can tell temperature, right? We can tell molar volume, then specific heat capacity, right? Specific heat capacity, refractive index. So likewise, boiling point, melting point. So likewise, these are actually independent of amount of mass. So these are the extensive and intensive. Now, what do you think about enthalpy? Enthalpy is a state function and extensive property. Yes, that's true. Yeah. Remember, we learned that Hess law. Can you remember in the Hess law, we are telling that enthalpy change of a reaction is independent from the path. Right? So that means enthalpy change is a state function. And the next thing is, it is an extensive property. Extensive means depend on the amount. Kilojoules per mole. Right? So here they have given enthalpy, right? Enthalpy. So therefore, depending on the amount. So therefore, the first statement is correct. Simple A is correct. Simple B, heat is not a state function, an extensive property. What do you think? Heat is not a state function. That's correct, right? Heat is not a state function. That's correct. But is that an extensive property? What do you think? Heat is an extensive property. Yes, we know that energy. Okay? Energy, we can consider heat is actually kind of a thermal energy. So they are extensive. So we can tell that that statement is also correct. B also correct. C, density is an extensive property. Density is intensive property. It doesn't depend on the mass or size. So therefore we can consider that is wrong. Then D, molar enthalpy is a state function, correct, and intensive property. What do you think? Students, remember, molar enthalpy means they have already defined the amount or size. So therefore, it's not depending on size or amount. So therefore, we can consider that statement is also correct. D also correct. A, B, D correct. So therefore, question number 12, what is the answer? Question number 12 answer is number 5. Okay. If you have any doubts, put your doubts in the chat box. So enthalpy change is a state function, right? Is enthalpy state function? Enthalpy change is a state function. Enthalpy enthalpy definition means we know that under constant pressure we are measuring the thermal energy of that reaction. So therefore enthalpy change is a state function. Yeah, yes. So they have to give the enthalpy change. Yes. Yeah, students, in the question number 12, the statement A, right? Enthalpy is a state function and extensive property. Yeah, it's correct. Extensive property is okay. But is that enthalpy state function? Enthalpy change is a state function. According to the Heslow, we know that enthalpy change of a reaction is independent from the path, right? But I gave you that enthalpy is a state function. No? Okay, right. Let's consider here enthalpy is not a state function, but enthalpy change is a state function. Okay, we can consider in that way. Enthalpy change is a state function. Enthalpy is not a state function. Then we can consider that the A statement is wrong. Okay, A statement is wrong. So if A statement is wrong, still the answer is number 5. Okay. So we learned that enthalpy and entropy are state function, right? So in second statement, they say it is neither state function nor extensive property, right? No. Kavisha, in the second statement, they are telling heat is not a state function and an extensive property. So that means separately think that one, okay? You have to take that one separately. Heat is not a state function. Heat is an extensive property. That's the way we have to think, okay? Right, Pranali, in the note that I gave you, enthalpy, entropy, both are state functions, right? Is that the way that I gave you? In the note, in theory note? Or else the enthalpy change and entropy change. What is it? Right. Okay, right. Doesn't matter. For now, let's take that enthalpy. Enthalpy is not a state function, but enthalpy change is a state function. I will clear this point in the next class, okay? I'll clear this point in the next class. Remember me, okay? Right. So anyhow, even though this statement is correct, we can consider the answer is number 5. If it is strong also, the answer is number 5. Question number 12, answer is number 5. Okay. Next one. The correct equation and the relevant enthalpy change is mentioned in. So they have given standard enthalpy of atomization. Students, look at this one. They have given atomization. Atomization enthalpy of chlorine. So what should be the atomization enthalpy of chlorine? That means delta H theta ATM of chlorine. So atomization enthalpy of chlorine should be Cl2 gas, Cl gas, 1 atom. So therefore we have to put here half. So this is the standard enthalpy change of atomization. Second one, standard enthalpy of solution. Actually, they have given the opposite of this one. Eh? The solution enthalpy should be sodium chloride solid plus water and producing sodium chloride aqueous. So this should be the solution enthalpy, right? And the next one, they have given the opposite thing. So therefore, simple A statement wrong, B statement also wrong. Then we can consider C, standard enthalpy of neutralization. Yeah, that's correct. Eh? Delta H theta, NEU, neutralization enthalpy. H plus aqueous reacting with OH minus aqueous to produce H2O liquid. So that is the neutralization enthalpy. Then next one, C statement correct. D is fusion enthalpy of aluminium. That means aluminium solid is converting into aluminium liquid. So therefore that's correct. C and D correct. Question number 13, answer is third one. Question number 13, answer is third one. Question number 13, answer is third one, right? Quickly complete this one. This is very easy. Right. Now let's go for the next question, students. Question number 14. This is related to the inorganic complex compounds and their colors, right? So we are going to learn these things in the upcoming sessions. So tomorrow also we have to discuss D block. So remember the first cation is they have given is hexa aqua manganese 2 plus. Remember actually the color of this one is pale pink color or light pink color. Okay, keep that in your mind. So this is pale pink color. So the second one, simple B, they have given hexa aqua chromium 3 plus. Hexa aqua chromium 3 plus. Students, according to a resource book, so the color of this complex is actually blue violet. Blue violet, okay? Blue violet is the color of this complex cation. And so they have given green color, so that is wrong. So the next one is chloride complex, tetrachloride of ferrate. What is the color? So the chloride complex color is actually yellow color, right? This is yellow color. Then D, hexa amine cobalt 3 plus. So we discussed this one in the third question also. Can you remember? Hexa amine cobalt 3 plus. So the color of this one is actually, we can tell that hexa amine cobalt 3 plus. We can tell that brownish red. Brownish red is the color, but here they have given what? Red brown. Yeah, both are same. Brownish red, red brown, both are same. Okay, so therefore we can consider that in this statement, A correct, B wrong, C wrong, and D correct. So therefore question number 14, what is the answer? Question number 14 answer is number 4. Okay, so D block elements. Don't worry, we are going to learn these things. Quickly come to this one. Students, remember in the D block we are learning some of the oxides formed by D block elements. Like manganese, chromium, like elements are forming oxides. First of all, let's go for the chromium. Chromium is producing CrO, Cr2O3, CrO2, CrO3. Oxidation numbers are +2, here +3, +6, +4, +6. Remember, chromium's +2 oxidation state oxide is weakly basic. And +3 oxidation state is amphoteric. Remember these things, okay? And this is CrO2. This is weakly acidic. CrO3 is, we can consider this is acidic. Okay. And the next one is manganese. Let's go for the manganese also. Manganese producing some of the oxides, manganese oxide MnO, Mn2O3, MnO2, MnO3, Mn2O7. Oxidation numbers are +2, +3, +4, +6, +7. So what is the nature? What is the nature of these oxides? Remember, manganese +2 oxidation state, we can consider this is basic. +3 is weakly basic. Then MnO2 is amphoteric. MnO3 weakly acidic. Mn2O7 is acidic. Yeah. In this way. Remember these things, okay? So these things are clearly given in your resource book. This is actually oxides of chromium. And others are the oxides of manganese. So they're asking here, question number 15, acidic oxides. CrO3, is it acidic? Yes. B, MnO, is that acidic? Oh, it's basic. C, Mn2O7, that is acidic. Remember, when the oxygen number of oxygen atoms are increasing, we can tell that acidity is increasing. CrO weakly basic. So therefore, only the correct one is, they're asking acidic oxides. This is correct. A and C correct. A and C correct. So therefore, answer is number 5. Question number 15, answer is number 5. Question number 15, answer is number 5. Okay. Yes. What are the doubts you have? So if they have given weakly acidic oxides also and asked for acidic oxide, we should include that also. Yes, we can include. Yeah. If they have asked about in that way, yeah, we can include that one also. Doesn't matter. Anyhow, that is acidic. No? Weakly means that is also acidic. Weakly acidic. These two oxides are basic. These two oxides are acidic, and this is amphoteric. Okay, students. Next one. Okay, quickly complete this one. Right. Okay. Are we done? Did you write down everything? Okay. Right. The relevant enthalpy changes for developing the Born-Haber cycle. Enthalpy of hydration, lattice enthalpy, lattice formation, enthalpy of formation, enthalpy of solvation. Students, enthalpy of hydration, enthalpy of solvation, not included in the Born-Haber cycle that we discussed. Neither. Lattice enthalpy is there, formation enthalpy definitely there. So therefore, B and C answer is actually they're asking irrelevant enthalpy. A and D are the irrelevant enthalpies. So therefore, answer is fourth one. So shall we quickly construct the Born-Haber cycle for compound? Let me take here magnesium oxide. Let's quickly construct the Born-Haber cycle for magnesium oxide. Let's see. Quickly, yeah. Magnesium oxide. Magnesium is a solid reacting with oxygen gas to produce magnesium oxide. So this is formation enthalpy of magnesium oxide, delta H theta F. So here we have to put half. And we know that magnesium solid converting into a gas, oxygen, monoatomic gas, and here we can consider O2 minus gas and magnesium 2 plus gas. These two gaseous state cations are mixing, connecting to form the lattice enthalpy, lattice of magnesium oxide, delta H theta. And solid to gas, we can consider this is the sublimation enthalpy or else atomization enthalpy of magnesium. And here we can consider this is, if you want, you can consider atomization enthalpy. If not, we can consider half of the bond dissociation enthalpy of oxygen. And from here to here, we can consider this is first electron gain enthalpy, delta H theta Eg1 plus delta H theta Eg2, second electron gain enthalpy. And from here to here, we can consider this is the first ionization enthalpy, delta H theta I1 plus delta H theta I2 in this way. So can you see any solvation enthalpy, any hydration enthalpy? No, right? So that's very easy. So irrelevant enthalpy changes are hydration and solvation, A and D. Question number 16, answer is fourth one. Question number 16, answer is fourth one. See how easy these things. Question number 17. So in this paper book, I need your marks, okay? So now for the structured essay question, out of 100, how much? For the essay paper, out of 150, how much? You have to calculate them, huh? And tell me. You saw the paper book, right? Before you come to the paper class every day, try the next paper that you have to do in the next paper class. So today I think we don't have time to discuss essay questions. You can try the essay questions. So I have given you space to write down the essay questions answers. So I'm going to give you the marks also for this one, the 5 marks likewise. Then finally you can count the marks out of 150 how much. Okay. Let's do the full papers also, but we have to finish some lessons to do the full papers. Okay. So until that, let's wait. In the last session of our last phase of our paper class, let's do full papers. Right. Now let's go for the question number 17. The correct statement regarding the thermal decomposition of S-block compounds. Simply, 2 gases are produced from the thermal decomposition of all nitrates. That's wrong, students, right? So just now we discussed that one in a previous question. Sodium nitrate is producing a solid compound and that is false, ne? Solid compound and oxygen. Let me take now here potassium nitrate producing potassium nitrite and oxygen gas, right? So in order to balance this one, put 2 here, 2 here. So this is group number 1. In group number 2, we can tell that, for example, if I take magnesium nitrate like compounds, so the thermal decompositions are like this, producing magnesium oxide, nitrogen dioxide gas, which is reddish brown gas, and oxygen gas is also liberated. Right? In order to balance this one, we can put here 2 here, nitrogen 4. So 12, so 8, 10, 12, the reaction is balanced. Okay. So therefore, that is not always giving 2 gases. That's wrong. Simple A statement is wrong. B, carbon dioxide can be obtained by the thermal decomposition of all carbonates. What do you think? Carbon dioxide can be obtained by the thermal decomposition of all carbonates. First of all the carbonates should thermally decompose in order to obtain. So therefore, that is wrong. Right? I told you that except lithium carbonate, group number 1, sodium carbonate, potassium carbonate, rubidium carbonate, cesium carbonate won't thermally decompose. So there won't be any carbon dioxide product. So therefore, that is wrong. This statement is also wrong. C, carbon dioxide can be obtained by heating solutions of second group hydrogen carbonates. What do you think? Is that correct? Yeah, correct. Ne? We can tell that. We can tell that. Let me take calcium bicarbonate. Calcium bicarbonate thermally decompose. What are the products? Calcium carbonate, carbon dioxide, and water vapor. Right? So then, in order to balance this one, 2 carbon dioxide, 4. No. Okay, balance. The reaction is automatically balancing. 2 hydrogens, 2 carbons, oxygen 6. So reaction is balanced. So you can see that carbon dioxide is liberating. They have given carbon dioxide can be obtained by heating solutions of second group hydrogen carbonates. Correct. That's correct. Okay. So therefore, C, statement C. H2O liquid, Asma, we can consider that since we are going to decompose this one thermally, definitely the thermal energy should be greater. That means since we are heating this one to high temperatures, H2O can be in gas. But if you take this reaction again to the room temperature, then this one can be liquid. Okay. If you write down this reaction with the liquid also, they will give you marks. It doesn't matter, right? So here we can say that A, B statements are wrong. C is correct. What about D? The thermal decomposition temperatures of second group carbonates increase down the group. Is that correct? Down the group, thermal decomposition temperatures are increasing. Yes, correct. Remember, students. So how do you explain this one? How do you explain this one? In the second unit, we learn about the polarizing power. Ne? Beryllium 2 plus, magnesium 2 plus, calcium 2 plus, strontium 2 plus. We can say that radius increasing. Then what will happen to the polarizing power? Polarizing power decreases. Therefore, covalent character decreases. Then ionic character increases. Then we can tell that thermal decomposition temperature, because ionic compounds are very strong, thermal decomposition temperature increases. Right? So these are the theories we learned. Okay, keep that in your mind. Then we can tell that, so the D statement is correct. C and D correct. Question number 17, answer is third one. Question number 17, answer is third one. What is the answer for question number 18? Intensive property. Just now we discussed density, temperature, volume, mass. Intensive property. Intensive means independent from the mass or size. Density independent, temperature independent, volume and mass they are depending. So therefore, density and the temperature answer is first one. Question number 18. Just read the question and go for the answers. Question number 18, answer is number 1. Right? Question number 18, answer is number 1. What about question number 19? Hydrogen bonds are found in HCl gas, sodium chloride solid, HCl aqueous, and acetic acid aqueous. Students, in HCl gas, how we can say hydrogen bonds? In order to show the hydrogen bonds, there should be electronegative atoms like oxygen, nitrogen, fluorine. Either. So therefore, we can't say that HCl gas is having hydrogen bonds. Then between HCl gas molecules, what are the interactions that we can see? Between HCl gas molecules, what is the secondary interaction type that we can see? What you can say? Yeah. London. Are you sure? Dipole. Yes. Remember, these are dipole interactions because these are polar molecules, right? So therefore, dipole interactions exist. Correct? Then the second one is NaCl, sodium chloride solid. Students, we cannot see any secondary interactions. Actually, we have a very strong primary interaction. What is it? Ionic bond. So therefore, we can't see hydrogen bonds here, right? So that's not possible. HCl aqueous, is that correct? Yes, of course. HCl aqueous means HCl is dissolved in water. Water molecules are there. Since water molecules are there, we can say that hydrogen bonds are existing. So the next one is acetic aqueous. I think acetic aqueous means water molecules are also there, and acetic itself, OH bond is there, so therefore hydrogen bonds can form. So therefore C and D correct, right? Among the given compounds, C and D are containing hydrogen bonds. So therefore question number 19 answer is third one. Question number 19 answer is third one. Okay, right? What about the 20th one? Are you very easy? A factors affecting the electronegativity of an atom of a molecular ion. Students, revise the electronegativity factors that we discussed. Number one, hybridization, right? When this character increases, electronegativity is increasing. Number two, oxidation number. When the oxidation number increases, electronegativity is increasing. Formal charge. When the formal charge increases, oxidation number is increasing. Fourth one is surrounding atoms. When the surrounding atoms are more electronegative, central atom is also becoming more electronegative. So therefore, these are the four factors. So you can clearly see that charge and hybridization, two factors are there. B and C correct. Question number 20, answer is second. So the last 5 questions among these 10 questions are easy, right? Okay, now tell me from question number 11 to question number 20. For those 10 questions, anyone here got out of 10 out of 10? Anyone here? Oh, good. Asma 9, no? Anyone here 10 out of 10? 9? Opeshani, Asma, Sehanti, 9. Very good, huh? Very good. What about 8? Yeah. Lashmi and Hima. Okay, very good. Yes. Nice. Right? Try to get 30 out of 30, at least 30 out of 28, 27 will be a good mark for this MCQ paper. Okay. Don't worry, just you can evaluate yourself. That's all, right? This is not your A-level examination paper, so just to evaluate yourself. Right. Now we can go for the last 10 questions. Tell me if you have any doubts quickly. We have discussed 20 questions. Do you have any doubts? How the Yunali, do you have any doubts? Anything? Can you understand the things that we discussed today? Yunali? Right, okay. Right. Now let's go for the question number 21. The statement type of questions. So there are 10 questions they have given. So let's finish this one also. Question number 21. The boiling point of ICl is greater than bromine. Look at this one. They have given to compare two compounds, ICl and Br2. First of all, tell me, when you are asked to compare the boiling point or melting point, what we have to do for these kind of compounds? You have to go for the secondary interactions that are existing, right? So the specialties are the next specialties, they are halogen. iodine, chlorine, bromine, all of them are halogens. So ICl, you can see that polar molecule. So therefore, dipole-dipole interactions are there. Then here we have London forces. So we know that generally dipole-dipole interactions are more powerful than London forces. Then what will happen to the boiling point? So the greatest boiling point belongs to ICl. That's correct. Okay? So the boiling point of ICl is greater than bromine. It's correct. Second statement they have given, bromine is a non-polar molecule. Is that correct? Yeah. ICl is a polar molecule. Therefore, dipole-dipole attractions are existing. Yes. Dipole-dipole interactions are existing in ICl. So we can say that the second statement is explaining the first one. Question number 21, we can say that answer is first one. Question number 21, answer is first one. Okay. Question number 22. Cathode rays are deflected towards the magnetic poles at the presence of a magnetic field. What do you think? So that means they have given that cathode rays are deflecting towards the north pole or south pole. Magnetic poles means north pole or south pole. So are the magnetic, that means are the cathode rays are deviating, deflected towards north pole or south pole? Is that the way we learn? No. Cathode rays are moving perpendicular to the magnetic field. So therefore the first statement is wrong. Second one, cathode rays are, that's easy, no? Negatively charged, that's correct. First statement is correct. Second one is wrong. Then the answer is fourth one. Question number 22, answer is fourth one. Just read the question and go for the answers. Statement type. Question number 23. Wavelength of the first line of the Balmer series is longer than the wavelength of the first line of Lyman series. Students, hydrogen emission spectrum. In the last year A-level examination paper also, they have given a question from hydrogen emission spectrum, right? So let's revise it quickly. Let me draw the energy level diagram in this way. N equal 1, N equal 2, N equal 3, 4, 5, 6. And we know that Lyman series is obtained when the electrons are falling to the first principal energy level. Never. So this is the Lyman series. Then we can say that Balmer series is obtained when the electrons are falling to the second principal energy level. So this is the Balmer series. The Balmer series is actually partly visible, right? We can say that this is Lyman. Lyman belongs to ultraviolet region. And this is Balmer. Balmer belongs to visible light region, but remember that should be partly visible light region. Partly visible light. Okay. So this is H alpha, H beta, H gamma, H delta. Can you remember? What are the colors? H alpha red color, H beta a green color, H gamma blue color, and H delta violet or purple color. Okay. So these are the Lyman series and Balmer series. I haven't mentioned the partial bracket form, no need, because here the comparison between Lyman Balmer. Wavelength of the first line of the Balmer series, 3:2 Balmer series, is longer than the wavelength of the first line of the Lyman series. Is that correct? Remember, we know that in the hydrogen emission spectrum, we learned for this direction, frequency and energy increasing. Energy and frequency increasing for this direction. Then what will happen to the lambda wavelength? lambda wavelength decreases for this direction, right? Are then increasing for that side. Then Balmer series has the longest wavelength. That's correct. Yeah, that's correct. The first statement is correct. When Lyman and Balmer series are considered, Lyman series belong to a region with a higher wavelength. Wrong. That's wrong. So therefore, question number 23, first statement correct. First statement correct. Second one is wrong. Answer is third one. Question number 23, answer is third one. Very simple question given from the hydrogen emission spectrum. Very easy. Okay. So you have school holidays neither. When they are giving school holiday? November 20, 22nd. 13th also holiday. 13 also. For election, yeah. 13, 14, 15. That means in that week you have, I think you have only Monday, Sunday, Monday and Tuesday. Okay? Because 14th election, Thursday. 13th is Wednesday. Then 15 poe day, Friday. We have class, okay? And Saturday, Sunday. Again, in the next week, you have school. 22nd, they are giving. Then they are starting school again in January, I guess. Because A-level examination is going to end up in 20th, I guess, 20th December again. Then after that one, you have Christmas and everything. So then again, they are starting properly in January. Are they keeping exams in November before they give holiday in your schools? Had Asma send me the paper, okay? What is it? FWC paper. Students, send me your school term test papers, okay? And if you have any doubts, tell me in those papers. They kept the third term test, okay? Right. We have on January. No. Okay, good. It's better have that one on January because in January, probably we are doing organic and kinetics also. So therefore better. Organic TUT is ready, yeah? So yesterday only I completed the TUT. So in this month, we are starting organic chemistry. Let's go for the question number 23. 23 is done. 24. Across a same period, left to right, the shielding effect is increasing due to the increasing of the number of electrons. Students, what is shielding effect? Can I remember first unit theories? Shielding effect means the ability to protect the valence shell electrons from the nuclear attraction. Actually, yeah, blocking effect. Neither. That's the correct term that I gave you, blocking effect. Now, when you consider sodium, configuration is 1s2, 2s2, 2p6, 3s1. So you know that, students, the valence electron is 3s1. Then these inertial electrons, so these are actually known as co-electrons. So these co-electrons are protected by this valence electron. So this is the valence electron, valence shell electron. So the co-electrons are protecting the valence electron. So therefore we can tell that, so the shielding effect is measured by number of co-electrons. So shielding effect means the ability to protect the valence shell electrons from the nuclear attraction force by co-electrons. So that is known as shielding effect. So the shielding effect is measured by number of co-electrons. So this is the shield, the protect. Across a period from left to right, shielding effect is increasing due to the increasing of the number of electrons. That's wrong. When you consider sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon, same period elements, they have the same shielding effect. Why? Configuration is actually neons configuration 3s1, neons configuration 3s2, 3s2, sorry, 3s2, and here we have 3p1. So likewise only 3s2, 3p1, 3p2, 3p3. Likewise, we have the neons configuration. So therefore, always the shielding effect is same for same period elements. So it's not changing. So therefore, the statement they have given is wrong. When going from left to right in the same period, the effective nuclear charge is decreasing because the atomic radius is decreasing. What do you think? Is that correct? Remember, students, what does mean by the effective nuclear charge? ZFF. Effective nuclear charge means we can tell that nuclear charge minus shielding effect. So we can consider that the equation is ZFF is equal to Z minus S, shielding effect. And we know that when the shielding effect increases, what will happen to the radius? Radius is decreasing. That means atomic radius inversely proportional to the shielding effect. This is how we learn, right? When it decreases, atomic radius is increasing. Then when going from left to right in the same period, the effective nuclear charge is decreasing because the atomic radius is decreasing. Look at this only. When we calculate the effective nuclear charge for sodium, what is it? Shielding effect, nuclear charge is 11. Shielding effect is 10, therefore plus 1. Magnesium, effective nuclear charge 12 minus 10, plus 2. Aluminium, effective nuclear charge 13 minus 10, plus 3. Then students, you can clearly see that effective nuclear charge is not decreasing, it's increasing. So therefore, the second statement is also wrong. First one is also wrong. So therefore, question number 24, answer is fifth one. Question number 24, answer is fifth one. Okay. Question number 25. Valence shell electrons participate for the chemical bond formations. Is that correct? Yeah, that's how actually chemical bonds are formed. Covalent bonds are formed by sharing the electrons. Yeah, that's also correct. But is the second one explaining the first one? Right? Is the second statement explaining the first one? No, right? So therefore no connections. Therefore we can tell that question number 25 answer is second one. Second statement is not clearly explaining the first one. Question number 26. In a balanced chemical equation, the number of molecules and the charges of both sides should be equal. Is that correct? In a balanced chemical equation, the number of molecules and the charges of both sides should be equal. Number of molecules. What do you think? Is that correct? Charge is okay. Charge should be balanced. But number of molecules? Oh, it's not like that. Now, for example, shall we take a reaction like this? Let me take here. Sodium, the same reaction that we took. Sodium nitrate, sodium nitrite, oxygen. So when you balancing this one, we have to put here 2 here. So tell me how many molecules are there in the left hand side? 2, ne? And here how many molecules are there? 3. So therefore it's not compulsory to have same number of molecules in the both side. Can you understand? Then what is the condition? That means what is the thing that actually should be equal? Masses, right? We have to consider that right hand side, left hand side mass and the right hand side, left hand side mass and the right hand side, both should be equal. Can you understand? So this is actually a law, mass conservation law, right? So left hand side mass should be equal to the right hand side mass. That is the sufficient condition. Okay, not the number of molecules, right? Keep that in your mind. So therefore, in a balanced chemical equation, the number of molecules and the charges of both sides should be equal. Wrong. Charges should be equal, but not the molecules. So this is one of the example that you see. The masses of the both sides of a balanced chemical equation should be equal. Yes, exactly. Mass conservation law. That's correct. Both the masses are equal, right? Then first statement is wrong, second one is correct. Question number 26, answer is fourth. Okay, right. Question number 27. So this is very interesting, right? Let's see your answer. Liquid takes the shape of its container, but it does not spread all over the container. Is that correct? Correct. Next one. The shape of liquid depends on the gravitational force. Is that correct? Yeah, that's also correct. Right? The shape of the liquid is actually depending on the gravitational force. Is that explaining the first one? This is kind of a physics question, right? It's not chemistry. Is that explaining the first one? What do you think? The shape of the liquid depends on the gravitational force. So that's why it takes the shape of the container. Yeah, correct. Because of it only actually it's having the shape of the container. So if the gravitational force is not there, will it take the shape of the container? What do you think? Just imagine you are going for the space, because in space we know that gravitational force is not affecting them. So then when you put a liquid to a container, will it take the shape of the container, that liquid? No, right? So therefore here actually the second statement is explaining the first one. Okay. So question number 27, answer should be first one. So this is not a chemistry question, actually, some kind of a GK variant, physics variant. Right? Question number 28. Volumetric flasks are used for the preparation of solutions with a known concentration. Yeah, we can use a volumetric flask in preparation of solutions. That's correct. Then the second one, in dilution of an acid, water is added to a known volume of an acid. What do you think? Is that correct? Water is added to the acid. Is that correct or wrong? Huh? How did I teach you in chemical calculations? We are adding water to acid, though, acid to water. Acid to water, eh? We have to add acid to water. We are not adding water to acid. So therefore, the second statement is wrong. So therefore, question number 28 answers third one. So you have to just read these things and go for the answers, right? Last 10 questions. But you should have the theory knowledge properly. Then only you can go for the answers. 29. The enthalpy of neutralization of strong acids and strong bases is a constant. What do you think? Is that correct? Strong acid and strong base neutralization is a constant. Yeah, correct. Because if it is a monobasic acid and monoacidic base, we can consider that is minus 57. If it is a dibasic acid, then twice of that one, but still that is a constant value. Okay, so therefore that's correct. The enthalpy of neutralization of weak acids and weak bases is quite different than that of strong acids and strong bases. Yeah, that's correct. Students, can you remember I told you that weak acids are actually not giving the relevant H pluses or OH minus to the medium properly. So therefore, just imagine acetic acid is reacting with sodium hydroxide, the neutralization reaction. This is producing sodium acetate and water. But remember, the enthalpy change of this reaction, we are expecting that should be minus 57, but it's not the correct one. It should be minus 54, something like that. Why? What happened to the remaining 3 kilojoules per mole? Yeah. So the remaining 3 kilojoules per mole energy is consumed to complete the dissociation of the weak acid. Because this is a weak acid. So sodium hydroxide need complete H pluses from the acetic acid. But acetic acid is a weak acid. It's not giving the H plus to the medium properly. Partially giving. So therefore, some of the energy is used to complete the dissociation of the weak acid. So therefore, the enthalpy of the neutralization of weak acids and weak bases are a little bit lower than that of strong acids and strong bases. Quite different. They have been quite different. Yeah, that's correct. Question number 29, answer is second one. Both the statements are correct, but second one is not explained the first one. What about the 30th question? Last MCQ question. S-block elements act as reducing agents. Remember, students, reducing agents means they can oxidize. Yeah. Sodium, sodium plus potassium, potassium plus magnesium, magnesium 2 plus. S-block elements are always reducing agents, right? Under certain conditions, right, okay. Students, hands up those who got this statement as a correct one. S-block elements act as reducing agent. Helium. Helium belongs to which group? Which block? SOPOD. S. Can helium act as a reducing agent? What do you say? They have given S block elements act as reducing agents. Can helium act as a reducing agent? Hydrogen is okay. Hydrogen can go for H plus. Helium, have you heard about helium 2 plus, helium 3 plus, helium plus? No, right? So therefore, this statement is violated when it comes to helium. Understood? So therefore, that's the issue here. S block elements act as reducing agents. That statement is not 100% correct. Okay, we can consider this is correct when we drop helium. So what we have to consider here then? Let's go for the next statement also. Under certain conditions, the metal of the group number 1 of S block undergo reduction by gaining electrons. Under certain conditions, the metals of the group number 1 S block of S block undergo reduction. No, metals are not undergoing reduction, right? They are always undergoing oxidation. The second statement is wrong, right? But when we consider hydrogen, that's correct. But hydrogen is not a metal. Hydrogen is a non-metal. Can you understand? So therefore, second statement is wrong. So let's consider that first statement is correct. Normally, generally, that's correct. S block elements act as reducing agents. That's correct. So except helium, actually, that's correct. So if not, we have to take two answers. Both the statements are correct. The first statement is only correct. So therefore, let me give both the answers. 3 or 5, both are correct. Question number 30. 3 or 5. Okay. Now tell me, anyone here got the correct answers for the last 10 questions, question number 21 to 30, 10 out of 10? Please raise your hand. Anyone got here 10 out of 10 for the last 10 questions? No. What about 9? 9? No. What about 8? Sehanti, Pranali, Asma. Okay. What about 7? Hima, Himani, Sukipi. Right. Okay. Good. Very good. Right. Okay. Students, what are the doubts you have? What are the doubts you have in this MCQ paper? In these 30 MCQs, do you have any doubts? Any doubts? Please raise your hand who understood the things that we discussed in these 30 MCQs. Okay, good. So in the 29th one, the neutralization enthalpy of diprotic acid is twice the neutralization enthalpy, right? So can we tell it is constant? Yes, it is a constant, right? That means for all the dibasic acids, that is a constant. That means minus 57 into 2. All the tribasic acids, that is into 3. So that is constant value, right? So when you consider strong acid, strong base, so that will be always a constant value. That means a multiple of 57. So therefore we can consider that's a constant, doesn't matter. Okay. Right. Okay, students, did you try the structured essay paper? Did you try this structured essay paper? No. Why only MCQ paper? Why didn't you try structured essay? You could have tried, no. So before you come to the paper class, remember you have to try paper, okay? Remember that one. Okay, now listen to this one. Now, before the next week class, you have to try these 2 structured essay questions and the 2 essay questions as well. I'm going to finish this paper, model paper 1, in the next week class. Okay, 2 structured essay questions are there, 2 essay questions are there, and MCQ, yeah, doesn't matter. In the next paper, MCQ, you don't have to try that one. So you have to finish those 4 questions, right? So what is the homework? Before the next paper class, you have to try 2 structured essay questions, 2 essay questions. Remember, now you can do these 2 structured essay questions in this way, right? This is the way. In the examination for the structured essay paper, students, how much of time they are giving for the structured essay paper? They are only giving 1 hour, right? So 1 hour means for one structured essay question, you have 15 minutes. 15 minutes. When you go for the essay paper, you are given 2 hours. So 2 hours means for one essay question, you are given 30 minutes. But remember, exactly in the examination, you won't get this much of time, right? But remember, normally, according to the hours they have given, this is the time. So you try to do the structured essay question within 12 minutes, Wagi, right? If it is 10 minutes, that's fine. But you can try the structured essay question within 12 minutes. And try to do the essay question by 25 minutes, Wagi. You can essay question 25 minutes වලින් ඉවර කරන්න බලන්න. හරිද? Then when you're doing the papers, what you have to do is for the structured essay paper, ඔයගලන්ගේ stop check ගන්න, clock එක ගන්න 12 minutes තියාගෙන 12 minutes වලින් ඉවර කරන්න බලන්න. Right? And take the essay question also and finish the essay question within 25 minutes. Don't take 30 minutes exact. Right? For these 2 essay questions, 30 minutes are actually more than enough. So therefore, no need to take 30 minutes, right? And then in the discussion, let's see how many marks that you got. That's how you have to practice essay papers. Remember, students, essay papers are not like MCQ papers. Now you have to do the papers. Now you have to practice the papers with time. Now in the previous paper books, we just discussed the papers, that's all. We didn't keep any time or anything. Now in these papers, we have to do the papers by keeping the time, and we have to find out our marks also. That's why I have given you these phases and the marks also. For the MCQ paper, remember, there are 30 MCQs. So you try these 30 MCQs within 40 minutes again. Right? Actually, you have to try these 30 MCQ within 30 minutes, but you can't do that one at the beginning. Understood? So therefore, you try these 30 MCQs within 40 minutes and check the out of 30, how much correct. In the next paper book also, I will include these kind of 3 papers, model papers, and let's see. So you need to see your improvements day by day. Now you have a lot of experience in students, right? So according to that post, did you see that? Okay, can you hear me now? Okay. So therefore, students, what I was talking about is, so we have done 400 plus MCQs, 25 structured essay questions, 20 essay questions in the previous paper books. So therefore, you have some kind of a now kind of a practice, and you have an idea about the papers, how they are giving the papers. So now you practice the time, right? In the examination, the most crucial point will be, the most critical point will be the time management. Especially you will feel that one in the essay paper. Mark my words, right? MCQ paper is okay. MCQ paper is manageable. Within 2 hours, you can do that. Anyone can do that. But essay paper is difficult. Difficult means in the sense the time will not be enough. So you have to practice the time. That is very important, right? Now, students, 24 batches going for the examination November, end of the November. So then you are the next batch. Now the game is actually starting properly for you all. So the next few lessons are also very important: organic chemistry, physical chemistry. So remember, definitely you have to do the papers. If you are not doing papers at home, if you are not working properly, you are done, right? But remember, if you are at zero level now, still you have the chances to go for 3 years. Doesn't matter. If you don't work properly in remaining months, you are done, right? So you can change your result from here. So therefore, do the past papers. Let's do the past paper discussion also. And in addition to that one, I will add that MCQ class. I told you something like that MCQ class. Separately, I'm going to discuss some MCQs, some difficult MCQs in that class. So let's see, right? So with these things, actually, you can go for your expected result, right? Okay, right. So next week, our plan is to discuss 2 structured essay questions and 2 essay questions. So you try those questions and come to the class, please, because I want to evaluate. I want you to evaluate yourself, and you have to check whether how much capable of doing an essay question. So therefore, please try those questions and come to the class. Okay. Then let's discuss these questions. After the model paper 1 discussion, I will give you the marking scheme. Hereafter, for each and every paper, I'm giving you the MCQ review and the marking scheme. Okay. You can refer that one later if you want. Right. Okay, then let's meet on the tomorrow theory class. D block we have to discuss. Then, tata bye. Have fun. Good night for all of you. Let's move to tomorrow class.